Hello and welcome to this 3D tutorial video for the Unity game engine. Today we are going to be making a 3D pool game, and all you need is Unity, which is free, and all these assets are free, and everything that will be included in this video is free, and follow along, and at the end you will have a playable game of pool or billiards, whatever you want to call it. This video assumes that you know at least a little bit about Unity and a little bit about programming. It's still a beginner's tutorial, but if you are an absolute beginner to Unity or programming, I highly recommend that you first check out our 2D tutorial project for absolute beginners. It will teach you everything. Well, it'll teach you the basics of Unity, starting from the very beginning, assuming you know absolutely nothing. That link will be in the description. All right, so let's get started and get these assets downloaded and start making this game. All right, so first things first is we need the assets. I will make sure I put this link in the description for you guys to go to. Once you have gone here, click on free download. It'll take a few seconds, but after it does, you will see this next page here, and you want to click on .fbx right over here on the download button to the right of that. And you will also want this textures.rar, so download that as well. If you don't already have a program to unzip that .rar file, I recommend 7-zip. I'll put the link to that in the description as well, and just download the version for your platform. All right, so I'm going to show making a repo here on GitHub. I know a lot of people don't know how to use it properly, so I'll show myself going through and creating one. So we're just going to give it a name. I'm going to set it to private, and I'm going to go here on the git ignore, and I'm going to choose Unity and click Create Repository. And you can see here's my repo. All it has is that .gitignore in it and nothing else. I also like to use GitHub Desktop. I'll have a link to this in the description as well. So I have Windows, so I'm going to click Download for Windows. And what this does is it makes using GitHub really easy. So once it's installed and you open it up, you'll see something like this or similar. So I'm going to go to File, Clone Repo, and I'm going to choose where I want to install it, and I'm going to search for the repository I just made. There it is. Make sure I know where it's being installed. I'll put it here in my Unity projects and press Clone. What that will do is bring all the files from your repository onto your local computer. So you can see here, if I go into my folder, there I have the .git, which lets me know it's a Git repo, and the .gitignore. So let's go ahead and unzip these. So you can see the .rar here. So I'm just going to right click on that and go to extract. And I'm just going to do it here in my downloads, hit OK. So let's go in here, and you can see it's just a bunch of textures, a bunch of images to use for our textures in our game. All right, let's go to the Unity Hub. We'll click New Project. I'm going to choose the 3D Core template. Going to go ahead and give it a name. And the most important part here is that you make sure, if you're using GitHub, that you choose the repo folder that you cloned as where you want to install this Unity project. So I'll go ahead and click Create Project. This will take a while. Okay, once it's open, you'll have this completely empty Unity scene here. If you go into the GitHub desktop, you can see that we have thousands of changed files. If you see that, it's an instant giveaway that you do not have your .gitignore in the correct location. So let's take care of that now. So here we are in our repo folder, and we're just going to take this .gitignore right here, and we're going to drag and drop it, or copy and paste it, or cut and paste, whatever you want to do, right into our Unity project. So you can see now when we open our Unity project, we have all of the Unity folders and the .gitignore is inside there. Now we only have 30 changed files. So we know it's working. So I'm going to go ahead and give this a commit message over here. Just say that I created the project and click commit to main. Once it's done that, I'm going to hit push origin, and it will basically take this Unity project and push it up onto GitHub. All right, let's get back in Unity here, and let's get our assets that we downloaded imported into our project. So all you have to do is go to the folder where you downloaded your assets. Mine are right here. And I'm just going to take this .fbx file. It'll say type 3D object. I'll just drag that in there. And all the models are contained in this one file. And I'll open up my textures, and I'm just going to grab this whole textures folder and just drag it in there. Okay, now that we have that, I'm going to rename it real quick. I don't like the T not being capitalized. And now we need to adjust some settings on the import of this 3D model. So if you just click on it, it'll open up over here. You can see we have a bunch of different information about the model, the rig, animation, materials. So just kind of go down here. I'm going to turn off cameras. And I'll leave lights on. And just make sure your settings match. Now we need to make sure that we get the materials set up correctly. So let's go to the materials tab. And you can see here, there are a bunch of materials and none of them are actually assigned a material. So click here on extract materials. And it's going to ask you where you want to install them. I'm going to make a new folder and call this folder materials. Okay, let's go inside there, hit select. And so now it will pull out all the materials and put them in this folder. And now you can look over and you can see that all of the materials are correctly applied. And I'm going to hit apply. And that will save all the settings that we changed there in the import settings for the model. You can see here are our materials in our material folder. And of course we had our texture folder and we have our model. So that's everything that we need to get imported into the project right now. So let's just click our whole model and drag it on into the scene. I'm going to click up here and hit reset to just make sure it's right in the middle, right at the origin. Just makes lining things up later easier. It's super white because the imported lights are too bright. So if you go up here to Window, Rendering Light Explorer, you can see all the lights in your scene in one spot. And I'm just going to turn the intensity of all of these back to 1. Now you can actually see the colors and you can actually see what's going on here. So this wall isn't in the right spot. Cool trick, if you hold V as in Victor and hover over a vertex, you can just drag it and it'll snap to other vertices of other models. So that looks pretty good. I'll just make sure this stuff on the walls. Okay, that looks good. And all right, yeah, let's go to Window, Rendering, lighting. And let's generate our lighting. That barely did anything, but oh well. And I'm actually going to select this directional light over here in the hierarchy, which is our sun. And you can see it doesn't really matter for this scene because we've got a roof on this building, and we're going to add the fourth wall that's missing at the end. So I'm just going to delete that directional light right there. I'm going to go to rendering, lighting, and generate the lighting again without the sun. Okay, so I'm only going to do this one more time for the rest of this whole tutorial, but it's a good habit to get in. Every time I change something, I like to do another commit and push it to my repo. That way, if I screw anything up later, I can go back and not lose a ton of work since I'm committing and pushing so often. So, like I said, I'm not going to show this again, but yeah, you can see all my change files, which are all those imported materials. It took a while to commit because it was, well, those textures are pretty big. So I'll hit push origin, and this is definitely going to take a while. And when it's done, that's it. So I'm going to keep doing this, but I'm not going to show it. So let's get started with probably one of the most important things of this whole game, which are the balls. So I'm going to click on this prefab over here, the whole FBX file over here, and go to prefab and unpack completely. And now it makes all of those individual items, and they're not prefabs anymore. Because the only thing that we're actually gonna duplicate are the balls. So I'm gonna click on the mesa here, which is the table, and you can see all the bolas, which are balls. The people who made this are Portuguese, so what do you expect? So yep, I'm just gonna grab bola 2 here. It really doesn't matter. I'm gonna make a new folder for my prefabs, and I'm just going to drag this ball here, number 2, down into the prefab folder. I'm going to rename it first. Drag it down in there, and there we go. So if we double click here, we can actually open the prefab up in this zoomed in isolated view. So it's I'm going to reset the position up here just to make everything easy. And I'm going to multiply everything by 100 on the scale, because the program used to make these models is in centimeters and Unity is in meters. So you need to multiply the scale of everything by 100, which it did on the things that we dragged into the scene, but it didn't do it on the prefab. And you can see that the ball that was still left in the scene is now massive. But if we delete that and drag in a fresh version of the prefab from our project folder, the ball will be the right size. So let's drag one in here. Let's adjust its position so it's up here on the table. And you can see that it is indeed the same size as the rest of the balls. So now let's get rid of the balls that are in the scene. So you can just click on them here in the scene view and select them individually. But if you hold Control, you can select multiple, hit delete on your keyboard, and you'll get rid of those. The other fast way to do it is over here in the hierarchy. Just click on the first one, hold Shift, click on the last one, hit delete on your keyboard, and let's get rid of that cue ball as well. Great. Okay, so now we have this empty table, and later on we will spawn the balls that we want on the table in the position that we want. So the next thing that we want to do is take this triangle, this ball rack over on the wall, triangulo in the hierarchy, and let's unparent it or drag it out of that parent game object so that it's by itself. I'm going to reset the scale over here to exactly 100, 100, 100, and I am going to start the process of getting this rotated correctly. Let's see. Okay, so there's its default rotation of 0, 0, 0. Okay, let's try 90. Let's do negative 90. I guess it doesn't really matter. It doesn't look like the top or the bottom are different. They look the same. So I do want to make this a prefab. So over in the hierarchy, let's grab it and drag it down to the project window. So now that is a prefab that we can use later. So let's just kind of switch to this overhead view using the gizmo in the upper right. This really helps see things. If you click the little square in the middle, it switches it to this like isometric mode. So there's no perspective included, which is really nice, and it makes it really easy to get things lined up. So let's drag this over here and kind of put it where we think looks like the middle. This doesn't have to be exactly perfect, so don't worry about getting the numbers exactly the same as what I'm doing. This isn't really crucial. So I'm going to click on the parent here, the table, and I don't know, to me it looks not straight, so I'm adjusting it a little bit. So I just feel like it's tilted a little bit to the side. -3, -2, -1. -1.5 on the Z for the rotation of that table. That looks way better. So make sure you set that rotation of that table to -1.5 on the Z axis. And I'm just going to keep moving my little ball rack to get it better centered. I'm just going to set the table back to 0 on the rotation. We'll deal with that later. This model isn't really perfect. Things aren't lined up great. Obviously you saw that one wall was like floating in the wall, and one wall doesn't exist, but we'll just try to make do. So I'm going to switch to this left view, and I can see that it was way above the table now. I'm going to switch back to isometric view. And I'm just going to drop it down until it is right there on the top of the table. Again, if you don't want to be this precise with yours, not a big deal. It's not going to affect the gameplay. Okay, so I'm going to switch back to perspective mode now with the little square in the gizmo in the upper right corner, and kind of look around. It looks good. Okay, so one thing to note, this pool cue here that we are going to use later is actually the same model as the ones on the walls. So we can expand it over here in the hierarchy, and you can see that they're not separate objects. So we'll just make do with that later, and yeah, let's sort that out later. Don't worry about it now. And the next thing I want to do is I want to do something with this prefab here. But first, let's go back to the assets folder, which is our top level folder of our project. Go to create folder, and I'm going to create a folder called scripts. Let's open it up. And I'm going to right click, go to create C# script. And this is going to be the script to set the game up. So I'm going to call it game setup. All right, let's let that compile. Okay, so I want to put this script on that rack because it's going to help set up the game. That's what it's for. So we're going to select the prefab, go to add component, and select game setup. And you can see that put the script right here on our prefab. And the one that's out there on the table also now automatically has that script on it as well. One real important thing to know is that if you have a prefab already in the hierarchy, like this triangle is over there, If we would have added the script on that one, it wouldn't add it on the prefab. But if you add it on the prefab down in the project window, it will automatically apply it to all of those instances of that prefab that are in the hierarchy currently. So let's just create all our scripts. I'm going to go ahead and create another one called ball. That one will go on our ball prefab. And I'm going to create another one called game manager. Now we've got all of our scripts here, and we will fill them out later and put them where they need to go. But for now, let's focus on this ball script. So let's open it up in our editor. And here we go. First thing I'm going to do is create a private Boolean that's called isRed. And this is to check to see if this is a red ball, or the only other option would be a blue ball. I'm also going to have a private Boolean here called is8ball and set that to false, because that's something the game manager will need to know. It makes the balls different. And another one that is cue ball. So that accounts for all the three different types of ball. It's either red or it's not, which means it's blue, or it's either the 8 ball or the cue ball. So let's create a public Boolean called isBallRed and have it just return if it's red or not. That's safer than accessing the property directly. And let's make another method here called ball setup. Ball setup's going to take a Boolean as an argument called red. And what our ball setup method is for is when the balls are spawning, it sets it up to be the correct type of ball. Either the 8 ball, the cue ball, a red ball, or a blue ball. I'm going to create another method here, public, make cue ball. I'm making all these public because we want the game manager to be able to call these methods. So make cue ball is just going to have is cue ball equals true. As you can see on line 29, we have ball setup. The only thing in there now is red equals red. And now we have this make 8 ball. And let's have it set is 8 ball to true. We're also going to do get component renderer, which will access the renderer that's attached to this object, which would be a ball. And we are going to modify its material, specifically the color property. And we are going to do color.magenta. So the 8 ball is going to be magenta. Similarly, we are going to basically do the same thing in ball setup for the red versus blue ball. So if isRed is true, we are going to get the renderer component that's on the game object that this script is attached to, access the material property, access its color property, and set it to red. Otherwise, so if it's not red, the only other option is going to be that we want to make it blue. So same code, except this time it is color.blue. And you know what? Now that I think about it, I don't want the 8 ball to be magenta. So let's just change this to black. One thing I want to say real quick is make sure you're saving your scripts pretty frequently, because if you don't, when you go back into the editor to test it, nothing will work. So you have to save your scripts. So I'm going to create another public Boolean here called isCueBall. All it's going to do is return if it is the cue ball or not. And I'm also going to have another one called is8ball. This also returns a Boolean. And it's just going to return is8ball, which is going to be, of course, a true or false value. Let's pop back over into the editor and set up our ball prefab. So right now, our ball is just a transform with a mesh, and that's it. But we're going to be hitting this around on the table, and it's going to be colliding with other balls. So let's put a sphere collider on it. Let's click Add Component, and we're also going to put a rigid body on so that it can interact with the physics system, and the sphere collider is so it can collide with other things. I'm going to expand the constraint section here in the rigid body and freeze the Y position so that the ball can't get hit up in the air off the table. And last but not least, I'm going to click Add Component and select the ball script. Now let's head back to our scripts folder, and I want to open up the game setup script. Let's start working on that. First thing we need to do is think, what do we want this script to do? Well, this is the game setup script. So it's going to be placing our balls in the rack at the start of the game. So it needs to know how many balls to place. It needs to know how many have already been placed. And it needs to have a reference to the ball prefab, so it can actually place ball prefabs. It needs to have a reference to where we want to put the cue ball. And it also has to know where we want to put the front ball in the rack. So let's just get started like usual with some variables up here at the top of the script. So I'm going to start off here with an integer, and this is going to represent how many red balls still need to be placed. So I'm going to call it red balls remaining and 7. I'm going to do the same except for the blue balls and set that to 7 as well. Okay, so this next thing might not be super obvious, but we are going to need the radius of the balls and the diameter of the balls. And we need this so that when we place the balls in the rack, since we will be doing it procedurally, they are all in the right positions and right up against each other and touching like they should be. So I'm going to make a float ball radius, and we're going to make another float for the ball diameter. Now let's think about our references. Well, like we said before, let's do serialized field so we can just easily drag it in the inspector. It's going to be a game object and the ball prefab. We need that so that we can tell it exactly what game object to spawn. Also, we're going to do a serialized field transform cue ball position, which will be where it will be placing the cue ball when the game starts. And we are also going to do one for the head ball position, which is going to be the front ball in the rack. Now there's actually a pretty easy way to get the ball radius. So here in start, let's set the ball radius. We are going to get the sphere collider component from the ball prefab. So ball prefab.getComponent, sphere collider.radius. Easy. And we're going to multiply that by 100 because remember, we scaled it up by 100. And then obviously the ball diameter is just going to be the ball radius times 2. So now that we've taken care of the things that the game setup needs to know about, we are going to start thinking about what are things that the game setup is actually going to do. As a rule of thumb, whenever you're writing your scripts and classes, just think that if you're thinking about things that it needs to know or data that it needs to work with, most likely it's going to be variables and some references to other things. If you're thinking about behavior, what kind of actions it can take, what actual things it's going to be doing, you're probably going to be writing some methods. So let's start writing some methods. What we're going to do today is we are going to, right now, just focus on thinking about what are the actions that this class is going to take, what do we want to call those, and we're just going to declare the methods. When I say declare the methods, I mean that we are just going to give it the method name, the types of parameters that it takes, the order, the names, whatever the return type is, and any other type of optional modifiers. But we are not going to write any logic inside the body of the method. And when you declare a method and you only type that first part, it's known as the method header. So what does this need to do? Well, it needs to place the balls. That's the number one reason for this script. So let's do void place all balls. It's not going to take any arguments. And so that is just declaring the method, and that's called the method header. So we also want to place the cue ball. It's going to be different. So place cue ball, and we're going to place the 8 ball separately as well. And so I'm going to do that, and I'm going to have it take in a position. So it's going to take in a vector 3, and we're just going to call it position. Then place random balls. So what is each one of these methods actually going to do? Well, placing the 8-ball, or place 8-ball, is only going to place the 8-ball in the position that is passed into it as an argument. Place cue ball is only going to place the cue ball in the cue ball position. Place all balls is going to place the cue ball, the 8-ball, and all the random balls. I'm going to start with place cue ball because that's the most straightforward out of all these methods and actually kind of does the least amount of stuff. So we're going to say game object ball equals instantiate, and the prefab to instantiate, which is the ball prefab, the location, which is the cue ball position dot position, and quaternion dot identity, so it retains the original rotation of the prefab itself. Now we can access that ball that we just spawned by saying ball dot get component, and we want to talk to the ball script and call the make cue ball method from the ball script. Place 8-ball is pretty easy too. So we are going to do the exact same code as before, except this time we're just going to use the position argument that's passed in as the location. So that's where position comes from in that line of code. And just like the place cue ball method, we are going to access it, and we are going to call that ball that just was spawned its make 8-ball method. Well, we know place all balls is definitely going to place a cue ball. So what's inside place all balls? Let's call the place cue ball method. We also know that it needs to put the 8-ball. So let's go ahead and put that in there too. So make sure that place random balls is being called by place all balls. Now, in the start method, we want it to place all the balls. So let's call place all balls up in start. Now, it is time to tackle place random balls. This is probably going to be the most complicated method of this whole tutorial. So let's just kind of break it down into steps and talk about it real quick before we start writing. So basically, this needs to place the first ball, go to the next row, place 2 balls, go to the next row, place 3, go to the next one, and place 4, and then go to the last row and place 5 balls. It also has to make sure that the middle ball, that is to say, the second ball that's placed in the third row, which is the row that has 3 balls, that second ball right in the middle has to be the 8-ball. So let's just tackle this one little step at a time, and we can do this. All right, let's go. So the first thing I'm going to do is I'm going to create an integer here right at the top of the method called num in this row, which is going to be how many balls in the current row we want to place. The first ball we're going to place is the head ball, so that's just going to be 1. I'm also going to declare this integer rand, which we will use for some random number generation. We're also going to declare a vector 3 called first in row position, which is equal to the head ball position. And that's going to be the first ball of each row, or the location of the first ball of each row. Well, the first ball is the head ball, so it's the same location. Then we're going to do a vector 3 current position, which is going to be the position that the next ball will be placed in. And since the first ball is the head position, the current position is going to be the same as that first in row position, which of course is the head ball position. Now, this place random balls method is basically just going to place red and blue balls over and over and over until they're all placed. So one thing that you should do when you're writing your code is if you know the same thing is going to happen over and over and over, it should be in a method so that you don't have to type the same, 5 lines of code or whatever it is over and over. And you can actually declare a method inside another method. And that is exactly what we're going to do. We are going to make one method to place a red ball, and we are going to make another method to place a blue ball. So that as we run through our loop of placing all the balls, we can just call those methods. So it's going to be void place red ball, and as an argument, it is going to take a position. So we are going to want to spawn a ball, just like the cue ball and the 8 ball above. And we need to save a reference to that so that we can modify it after it's been spawned. So if it's a red ball, we have to do something special. So we are going to access the ball script on that ball that we just spawned, and we are going to call its ball setup, and we're going to put true. Now remember, the ball setup method takes a Boolean as an argument. If it's true, that means it's a red ball. If it's false, that means it's a blue ball. And then the red balls remaining, we'll do minus minus, which means subtract 1 from it, and then set the new value equal to what it was before, minus 1. Now, the blue balls. They are also going to take a vector 3 as an argument, and we're going to call it position. I'm just going to copy and paste all of that there, and make sure that I change ball setup to false, and make sure that it is subtracting from the blue balls remaining and not the red balls remaining. Okay, so now is when we are going to want to write the logic that is actually going to spawn our balls and spawn them in the correct pattern, which is this perfect equilateral triangle of the balls in the rack position. So this is going to consist of, like we said before, place 1 ball, go to the next row, place 2 balls, go to the next row, place 3 balls. So we know it's just going to be some sort of loop. So we are going to use a for loop. And specifically, we are going to use a nested for loop. So we're going to have one outer loop and one inner loop. So the outer loop is going to be what is switching rows, and the inner loop is going to be placing all the balls in the current row. So for instance, when the outer loop hits its first iteration, it's just going to jump into the inner loop and place a single ball. That's the head ball. Then the inner loop is going to finish. It's going to jump back to the outer loop, and that's going to progress it to the next row. And then the inner loop's going to run again, but this time it's going to run twice to place 2 balls, and so on. So let's get this started. So start it off like any normal for loop. For int I equals 0. We are going to do I is less than 5 because there are 5 rows. And we're going to add 1 to I after every outer loop finishes. Now the inner loop, unlike the outer loop, which can just run from 0 through 5, is actually going to be having a different amount of iterations depending on which row it's in. So when we write this one, we need to make sure that it's not running from 0 to a set number, but it's running from 0 to some variable number that we can change when the rows change. So we're going to start it off just like a for loop. Let's call it j this time. It is going to start at 0, but this time it's going to continue until numbers in this row. Then it's going to add to j. So remember, numbers in this row is how many balls should get placed in this row. So that's starting off at 1. You can see that up at the top of this method. And so the first time it's only going to place 1 ball. Now remember, we do have one special case, and that is that the 8 ball, which is going to be in the 3rd row, the second ball, which is the one in the middle, has to be the 8 ball. So let's write a check to see if that's the ball that's getting placed and make sure that it puts the 8 ball there. So we're going to start off with a simple if statement, and we're going to say if I is equal to 2 and j is equal to 1. Then what are we going to do? We are going to place 8-ball. And we're going to call that method right there. And we're going to pass in current position, which gets changed throughout this loop. So let's kind of look at that line that we just wrote on line 68, the if statement, in a little bit more detail. So why is it I equals 2 and j equals 1? Well, we have these for loops starting at 0. So 0 would actually be the first row, 1 would be the second row, and 2 would be the third row. So by saying if I is equal to 2, that's saying if you're on the third row. J also, 0 would be the first ball in that row, 1 would be the second ball in that row. And this is the third row, so there will be 3 balls. So j equals 1 means the second ball, which is the middle, which is the 8-ball. If it's not that particular position, meaning that it's any other position in any other row, and there are at least some red balls remaining and some blue balls remaining, so red balls remaining is greater than 0 and blue balls remaining is greater than 0, we are going to generate a random number between 0 and 1. Now, it says 0, 2 because 2 is not included. 0 is, 2 is not, so 0 and 1. If it's a 0, we're going to place a red ball at that current position. Otherwise, we're going to place a blue ball. So we have another situation, which is that we do not have both red and blue balls remaining. So let's check to see if we have some red balls remaining. If we do, then we're going to place a red ball. And the only other possible situation we could have is that we have blue balls remaining, but we don't have red balls remaining. So else we will place a blue ball at the current position. Now we need to make sure after each iteration of this inner loop, we update the current position so that the next ball that's placed is not in the same position as the previous one. So the current position is going to be increased by vector 3, 1, 0, 0, which means to the right, normalized, so it strips off magnitude and only preserves direction, multiplied by the ball diameter, so that the balls aren't intersecting. After all of the inner loops have gone through, before it goes back to the outer loop, which would change rows, we are going to update where the first ball in the next row is going to be by adding vector 3 minus 1 comma 0 comma minus 1 dot normalized and multiply that by the ball diameter. So this is going to move it down and to the left. Then the current position is going to become that new first row position, and we are going to increment numbers in this row, and then it's going to jump out back to the outer loop, and it's going to progress to the next row, and it's going to run through, and it's going to place one more ball in that next row than it did in the row before. So this is a pretty big method. It's kind of messy. We're probably going to have to come back to it later. So just so we remember, let's put some comments in here. So the outer loop is the 5 rows. The inner loop is going to represent the balls in each row. Adding comments like this is good when you have a messy method like this, because you will be coming back to it and you will forget what all of the code you wrote is for. So let's continue and add some more comments throughout the rest of this so that there's no question why we wrote each line of code when we come back to look at this. So right here, this is going to check to see if it's the middle spot where the 8-ball goes. And then of course right here, if there are red and blue balls remaining, that's when it's going to randomly choose one and place it. Otherwise, it's going to see if there are only red balls remaining. And if there are, it's going to place one. and otherwise it's going to place a blue ball. And our current position line here, we're going to move the current position for the next ball in this row to the right. And last but not least, once all the balls in the row have been placed, move to the next row. Okay, now that that is done, let's hop back into the editor and let's start adding some colliders so that the balls don't just fall through the table. Now, these models, or at least some of them in here, do have mesh colliders on them, but mesh colliders don't really work for something like this, especially because there's a bunch of weird shapes on the top of this table, like the holes in the corners, and the mesh collider, it actually won't work. So let's right-click in the hierarchy, go to 3D Object, and create a plane. This is going to be what we use for the table surface. So I'm going to reset the X and Z positions to 0, move the Y to 1. So 1.007 is perfect because a little bit lower and it's kind of clipping with the table. We want it to be, I'd say, right above the surface is better than a little bit below the surface. So I'm just going to scale this down to try to get it to match up to the table as best I can. So I'm just going to keep switching between the scale tool and the move tool, which I'm using the hotkeys W for the move tool and R on the keyboard for the scale tool. You can also use E for the rotate tool. T is for what you'd use to move around like UI objects and stuff. And Q is just to pan around the scene. So I'm going to rename this tabletop now that I've got it how I want it over in the hierarchy. So if we would have used the original 3D model, we would have had to turn this on, the convex. And you can see that it just screws up the collider. And that's why we had to make our own. So make sure the tabletop does not have convex checked. Let's go to our prefabs folder, grab a ball prefab, get it out on the table, and we want it to sit exactly on the tabletop. Right now, the center of the ball is exactly on the tabletop. And we know that because we put the tabletop at 1.007 on the y-axis, and this ball is right at 1.007 on the y-axis. So we need to raise the ball up on the y-axis in an amount equal to the radius of the ball. And the radius is right down here on the sphere collider. So let's select it, hit Control C to copy it. And we're going to use that up here in the position on the x-axis. We're going to click in there. We're going to hit plus, open parenthesis, 100, multiplied by, Control V, close parenthesis, enter. There we go. We had to multiply it by 100 because of the scale. Because that radius down there on the sphere collider is not taking into account the scale. So we had to multiply it by 100 before we added it to the Y position of the ball. Now that we have a perfect Y position to get our balls right on the table, let's right click over here in the hierarchy, create empty, and we're going to call this cue ball pause, which is going to be the position for our cue ball. And all we have to do is copy this value right here in the ball on the Y and paste that into the cue ball pause on the Y. And now that has the same Y value as the ball that we were using to test the perfect Y position. So I'm going to switch back to this overhead isometric view. And let's actually go back to the table here because it is a little canted. And I said we'd come back to it, and we should. So, oops, that's not what I want. Okay, that X should just be -90, so it's a flat surface. The Y is what we want to rotate around. So, oh, other way. Too much. That looks close enough for me. Negative 1.75 rotation on the y-axis for the table. Cool. All right, I think that looks pretty straight. So, yeah. Okay, cool. And we also need to rotate this triangle. So, okay, the position's fine. It's that Y rotation that we need to do. And we're going to make it the same as, let's go back to the table, that negative 1.75. So let's go to the triangle, negative 1.75 in the Y rotation. Great. Now that looks like the triangle is facing straight down the table and their rotations match. I actually want to move the table to X position 0 and Z position 0 so that it's easier to put that cue ball and the head ball centered. I'm going to adjust this. Oh, that was the actual table. I want the tabletop. There we go. And just to, I mean, we did technically move the table a little bit, so I'm just going to kind of move this around a little bit. So again, just a little bit of scaling, maybe some moving if it's necessary. Okay, that looks good. All right, let's get these the cue ball position in the correct spot. So because we moved the table, let's select the cue ball position, set its X to 0, its Z to 0, and we'll keep that Y, because remember that's perfectly on the tabletop. And let's try Z1, that's 0.9, 0.8. Sure, that looks good. All right, now the triangle. We can also reset that to X0 and Z0. That doesn't look perfectly centered to me, but it's good enough. So now that we have that where we want it and the cue ball positions where we want it, we need the head ball position. So I'm just going to select the cue ball position, duplicate it with Control D, and then I'm just going to move it, the one we just duplicated, down to here. And I'm going to rename that head ball pause. And it looks good enough. So we don't actually need to use this triangle rack for the balls. So I'm going to select it, and here on its mesh renderer component, I'm just going to hit that checkbox right here to turn it off. So it's still there. The game object's still there. The script is still on it and everything. It's just invisible. Let's move this head ball pause to X0 and Z0, so it's right in the middle. Double check that cue ball pause. Okay, it's good. And now we can delete the ball that we placed in the scene. Let's open up the ball prefab and let's swap out that material bola 2 for material bolas. It's just an untextured ball. Let's go down to the rigid body on the drag option and set that to 5 and hit the little back arrow, and we're back in the scene view. Now we have to make sure that we drag those references to the cue ball pause, the head ball pause, and the ball prefab to our triangle, or we'll get null reference exceptions. So let's drag the ball prefab in there, drag the cue ball position in there, and drag the head ball position all into our triangle. Perfect. Now they have references to those. Let's hit play and test it out. And that is definitely not right. It looks like maybe some of the balls got pushed. I'm not sure. Let's exit play. I'm going to check out the ball prefab. Okay, it's got some drag. It shouldn't have been pushed that far. just from spawning next to each other. Let's look in our game setup script here. So one cool thing we can do is up here in start, let's, right before it places the balls, we'll do debug.break. And what this does is when it hits that line in the code, it will automatically pause the game here inside the editor. So let's hit play. It pauses it immediately. Okay, so the balls were getting pushed, but they're also not spawning in a perfect equilateral triangle. So we've got two issues. They're spawning with their colliders overlapping, pushing each other out. That's how they got a little more spread out. But the pattern's not right. So we need to fix the pattern, and hopefully when the pattern's fixed, they won't be intersecting when they spawn, and so they won't push each other apart. So let's just step through frame by frame. We can see that they were touching when apart. All right, let's exit play mode. And I think I actually know what the problem is. Let's go back to our game setup script. Okay, and right here, this is where our formula is messed up. So we're not getting the right first position for the ball in a row. So the actual formula is going to be vector3.back, which is backwards, times math f dot square root of 3. Then we're going to multiply that by the ball radius, all in parentheses, and then we're going to add vector3.left times the ball radius. Okay, let's try that. So let's hit play. Perfect. They're not touching. We'll step through. Yep, frame by frame, nothing. Unpause it. Yep, they're not moving. Cool. They're not intersecting, and the pattern's right now. Okay, let's go back to the game setup script and get rid of this debug.break in the start method, since we don't need that because the balls are actually getting placed correctly now. All right, let's hop back into the editor, and I want to hit play again. Cool. Okay, let's go to the ball prefab and actually set the drag to 0 and hit play again. I just want to make sure they're definitely not intersecting. Okay. So if they were, they definitely get moved since the drag is at 0 now. Okay, so now we have to do something tedious. Let's select this tabletop and size it correctly. So you can see on the edge of this table, you can see where the walls start. So I'm going to try to size this tabletop as best as possible to kind of end right there. And the reason we can't just have it going out like we had it before is now we need to start thinking about, okay, the balls actually have to fall in those holes. So you can see the problem on this corner right here. Obviously we don't want that. The balls won't be able to fall in that hole. So we need to adjust this in both the X axis and the Z axis like this. I'm going to stop talking for a little bit here and just focus on getting this set up. Feel free to keep watching, or you can skip ahead a little bit and just see what my final scale and position values are for this tabletop and set yours to be the same. Okay, our tabletop is positioned correctly, but there's two little gaps on either end. So I'm gonna select the tabletop, Control D to duplicate it, and I'm just going to use that shape to make these kind of like end caps for the floor. So again, I'm not really going to talk while I'm doing this. I'm just going to scale and move it around, and to make sure that it is perfectly lined up with the other tabletop, I'm going to use our little trick from before where I hold V on the keyboard and click and drag from one of the corner vertices of this little end cap to a corner vertice of the main part of the tabletop, so that I know there's no little bump there for the balls. Okay, I cannot get this end cap to snap to the right thing, so I'm gonna hide the table. So over here, there we go. You just click the little I over to the left of the name of it in the hierarchy. Now I can easily snap it on and hit the I again, and it will show everything again. And now I can just fix that X position and get it back into position. Okay, I'm happy with how that looks. I'm going to rename it real quick. I'm just going to call it tabletop bottom, I guess. And I'm going to Control D to duplicate that. And I'm just going to drag it along here. And hopefully that should be like the perfect length for this other side. And if it's, I'm going to rename it real quick. If it's not, then I'll just adjust it a little bit more. And I'm going to use that trick from before to hide the whole table so that it's really easy to use V to grab the vertex and snap it to the main tabletop object. Now, just one thing to say, we have to remember that when we get to the next step and we start building the walls, we have to make sure that we are not just taking a wall and running it down the whole length of the table, because that's going to cover up the holes. So we need to make sure we leave those open. Okay, I'm happy with how that looks. If yours isn't exactly like mine, not a big deal. All that matters is that it works. I'm going to grab these table surfaces that we've made and the cue ball and head ball position. I'm going to shift click to select all of them. And I'm going to make them children of the mesa, so that if we do move it, all those move with it. Okay, now we have to do the walls. Cubes kind of make sense here. So I'm going to go in the hierarchy here. We're going to right click, create empty. No, let's do 3D cube. Yeah, we could do empty, but cube's easier because we can visualize it. And then what we'll do is later, we can make them invisible so that the colliders remain, but we don't actually see the cubes. So like before, we're going to scale, we're going to move them. And when we get things set up the way we want them, we are going to use Control D to duplicate them and then just move them to the opposite side of the table to save us some time. And Again, yours does not need to be exactly like mine. I'm not going to talk through this until I get to a point where there's something important to say. So if you want to skip ahead a little bit or turn the speed up really high, that's totally okay. Do it on your own, set them up. Again, it just has to work. It does not have to be perfect. And don't forget, don't cover up the holes. Okay, I am quite happy with how that looks. I'm going to select all of these that I just made, and I'm going to also make them children of the mesa so that if we move it, it moves these colliders with it. So shift click, and I'm just going to drag them up there and drop them on the mesa. And now we are going to do what we talked about earlier and make them invisible. So you could click this little checkbox on the mesh renderer, or you can remove the mesh renderer like I just did, or you can actually remove the mesh filter as well. It doesn't matter. Either one will make sure that it doesn't show up, but the collider box is still there and it will retain its shape. So let's go ahead and remove either the mesh filter or the mesh renderer on all of these. Okay, now all of those are invisible, and we have another job. We need to add yet more collider boxes, because right now, if a ball goes in the corner, yeah, it can fall in the hole, but it also just completely falls out of the table and goes flying. So we're going to need to put some more colliders behind the holes. So that means on the sides here, we just need something that runs behind them. And on the corners, we're going to need two cubes that meet together at a 90-degree angle. And again, doesn't have to be perfect. You can use Control D to duplicate these colliders and move them around. I'm going to do this. I'm not going to talk much. Um, and I'll talk again once I finish this up. Okay, perfect. Everything's blocked off. The balls cannot leave the table. They will fall in the holes, but they're just going to fall through the world. So we need some way to catch the balls when they fall and do something about, the logic of what happens when a different ball goes in. So over here in the hierarchy, let's right click. Let's create a 3D object cube. I'm actually going to call this game controller or game manager. And this is going to be underneath the table. And this is essentially going to be the collider that not only detects when the balls have gone through the holes, but we're also going to put our game manager script on this object so that it doesn't have to communicate across any other scripts to handle the collisions of the balls dropping through. So let's just get this lined up, switching to the different views here to make things easy. We could also go to isometric if we wanted to. And again, it doesn't have to be perfect. If there's a little overlap, it's not a big deal. If there's a tiny gap, it's not a huge deal. We just don't want a ball to be able to fall through one of the holes and not also end up going through this collider box here. We also don't really want this to be a solid object. It's just going to be like a zone that the balls pass through as they fall through. If we forget to do that, it might cause some issues if it is intersecting with the bottom of the edges of the collider. So let's just go to the box collider, make sure we check is trigger. I'm going to remove the mesh renderer component so it's invisible. I'm going to add component, game manager, and so now we've got our game manager collision thing for the balls going in the holes. Let's do the UI next, because that's something that's easy to get set up. So let's right click in the hierarchy, go to UI, and text Mesh Pro. Import the TMP essentials, click on the button there. And when it's done, you can close that little window. Okay, let's select our canvas, go over here to the right in the inspector to the canvas scaler and set this to scale with screen size. I'm going to set this to 1080p. All right, I'm going to go to my game tab and just double check what my aspect ratio is set to. Okay, it's 16:9, which is the most common aspect ratio. Okay, before we move on, do not forget to set the UI scale mode on your canvas to scale with screen size. If you don't do that, you have no way of knowing what the UI is going to look like on other people's screens, because they might be in different resolutions, they might be using different aspect ratios, and if you forget to set it to scale with the screen size, it could cut stuff off. Stuff could be so big that it just gets pixelated, looks awful, and things could also be so slow that they're absolutely just completely unreadable. So it's very important that you don't forget that. All right, let's move on. Okay, so select your canvas, hover over the scene view, and hit F to zoom to where you automatically see all the canvas. We're going to use our little widget up on the top to get the correct angle, rotate it around. Okay, so let's select this text object here, and I'm going to rename it to player 1 ball count text. And this will be the part of the UI that tells how many balls the player 1 has. And I'll duplicate that with Control D, and we'll rename that one player 2 ball count text. Actually, I'm going to delete that, and I'm going to get this in position first, because it'll be easier to position the second one if we position this one first before we duplicate it. So I'm just going to set the text over here to player 1 balls remaining, X, just so we can see how much space it's going to take up, or I'll just put it to 7, because we know that's what it's going to start at. Okay, so I'm going to use the rect transform tool, which is T on your keyboard, to quick select. And I'm just going to get the size right. I'm going to go over here in the inspector and set it up to the left corner and hold Shift and Alt and click on that upper left corner button. And now you can see its position is relative to that upper left corner now instead of the center of the screen. So let's move it -10 on the Y and 10 on the X to move it away from the edge of the screen a little bit. We can click the game mode here and look at it. That looks good. Okay, now that we've got this one looking how we want it, I'm just going to double check it again. Okay, now we can duplicate this one, select it and hit Control D. Let's rename this one to Player 2 ball count text. And we'll just move that down a little bit. It's always better to use the rect transform tool instead of the normal transform, just because then things will snap to each other. So it's really a lot easier to get your UIs looking good. So I'm going to change the text over here. And then let's hop back to the game view here. Okay, that looks pretty good. That's okay. If you want to move yours around, you think they look better somewhere else, or change the font size or whatever else, whatever looks good to you. So I'm going to duplicate that again and call this one current player turn text. Move it to the upper center by clicking on the upper center in that little box, shift clicking, and then alt clicking. Move the Y position down, -10. And I'm going to change the text to player was. Now, I'm trying to think how I want to phrase this. Let's do current turn player 1. And let's see. Okay, that looks good. We also want to have a huge message that shows up right in the center of the screen for things like, player 1 lost or player 2 won, something like that. So duplicate that again, call it message text, and let's, over in the inspector, click in the middle, shift click in the middle, alt click in the middle. It'll move it to the middle, reset the pivot, and that's too small. So let's set the font size 50, 100, 80. That looks good. So I'm just going to drag it all the way across and make it a little bit wider here, just altering this height. And I'm going to set it right to the middle with the alignment option over here in the Text Mesh Pro component. And there we go. That's examples of what might show up in the message. Let's try something long. Okay. I think this will sufficiently handle any sort of message text that we need to put here. So we don't want the message text to be showing right when the game starts. So we can either disable the whole game object, or we can disable the Text Mesh Pro component. So, so if you click the check, you won't see it. But I think we should hide the whole game object. So I'm just gonna, up at the top here, click the little check and you see that that turns off. Let's open up our ball prefab, and up here you see where it says tag untagged. Let's click add tag, click the little plus button, and we're going to add a ball tag. And this is to make it easier to search for the balls when the game's running, check collisions to see if it was a ball or not. Make sure you go back into the ball and actually set the tag to ball, because creating a new tag, even if you did it from a game object, doesn't apply it. So you have to go back into the prefab, go to the tag you just made, and apply it. So let's get to work on this game manager script. The first thing I want to do is have a way to tell whose current turn it is. So let's create an enum called current player, and we will say player 1, player 2. So an enum is basically a user-defined value type that represents a list of constants with names. So player 1, player 2. So current player, and a Boolean for is winning shot for player 1 and is winning shot for player 2, both set to false. Those will keep track of if they're on their final shot, meaning they have no balls left and they're trying to hit the 8-ball in. Also, we need to make sure we have references to the player balls text so that up above those two lines, the player 1 balls remaining and player 2 balls remaining, so we can link those up. All right, so we also need our current turn text. And we need our message text. So there's our references to our 4 UI objects. Let's add a restart button later. So I'm going to add a serialized field reference to a game object. That'll be our restart button. And I'm also going to add a position here for us to drag in that head position. And not the head ball, but the cue ball. And that'll be a transform. And in start, the current player is going to be current player.player1. And let's just start getting some method headers down here. So we'll have scratch, which returns a Boolean. Let's have early 8-ball, which does not return anything. Let's have scratch on winning shot. That will not return anything. And let's do no more balls, and that won't return anything either. Let's do Boolean check ball, which takes a ball class as an argument. And let's do void lose, which takes a message, which will be a string. Void win, which takes a player name, which will be a string. And we are going to need a method to switch from one player's turn to the next one. So let's do void next player turn. And because our game manager script is on the trigger collider for the balls, we'll do on trigger enter collider other. Let's go ahead and just in these Boolean methods, the check ball and scratch, let's just put return true in check ball and return false in scratch, just so we can work in the rest of the script without having those errors for methods that aren't returning a value. Let's fill out the scratch method first. what it's basically going to do is if someone is scratched, well, the first thing we're going to do is check to see if the current player is player 1. If the current player is player 1, we're going to check to see, is this the winning shot for player 1? Meaning they only have the 8 ball left. If it is, then we will call scratch on winning shot. And well, it doesn't take an argument, but okay, yeah, this makes sense. So let's change scratch on winning shot to take a string, which is the player name. So if it wasn't player 1's turn, the only other option is it was player 2's turn. So we'll have else, and then we will check to see if it's the winning shot for player 2. Then we will call scratch on winning shot, and this time pass in player 2 as the string. And we are going to return true if they did lose. If they didn't, and it makes it to the end of this method, we are going to go to the next player's turn, and then we are going to return false. In early 8 ball, first we're going to check to see if the current player is player 1. Then player 1 is going to lose, because if you hit the 8 ball in before you get all your other balls in, then you lose. So lose takes a string, which is the whole message. So it's player 1 hit in the 8 ball too early and is lost. And then otherwise, the only other condition is that it was player 2's turn when an early 8 ball went in. And in that case, we will call lose, but then this time it'll be player 2 hit the 8 ball too early. So scratch on winning shot. This is just an immediate loss for whoever did that. So it'll just immediately call lose, pass in the name of the player, and then finish off the message with scratched on their final shot and has lost. And notice how easy it is to just add a string variable together and then a string after it. So for no more balls, let's change it to take in a player. And we'll say if the player that was passed in is is player 1, then what we want to do is we want to make sure that we turn is winning shot for player 1 to true. Because as soon as you run out of all your balls, you are on that winning shot, meaning that you have to hit in the 8 ball to win. And otherwise, turn on is winning shot for the second player. So we'll come back to check ball, because that's actually going to be the most complicated method in this class. So lose is pretty simple. We are going to get that message text reference. We're going to call the game object on that, and we're going to set it active to true. Remember, by default, when the game starts, that message text object is turned off. So set active to true turns it back on, so we'll see it. Then we set the message text.text to whatever message we pass in to lose. And then we will make the restart button visible as well. And remember, we haven't made that reset button yet, but we do have a reference to it in the code already. Win is extremely similar to lose. You're going to pass in a string player, and we're going to make the message visible. We are going to display that that player has won, and we are going to show the restart button. next player turn, we are going to check to see, that's not right. Yeah. Okay. We're going to check to see if the current player is player 1. If they are, then it's going to switch to player 2's turn. And we are going to change the current turn text to current turn, space, player 2. Otherwise, the only other option is that it was player 2's turn. So in that case, we are going to set the current player to player 2. And we are going to set the current turn text to current turn, player 2. Or sorry, player 1. So here we are going to check for the collision for when a ball falls through the hole and goes through the trigger that has this game manager script on it. So if other.gameObject.tag is equal to the ball, which is saying if the collider that's attached to the game object that fell through and went through the trigger, if the tag on that object is ball, then we're going to do if check ball, and we're going to pass in the ball script on that ball that fell through the trigger. If it returns true, we're going to destroy the ball or the game object, attached to the collider, which was a ball. Otherwise, we are going to move the cue ball back to the default spot, because check ball returns true for every condition except where you scratched and no one won, no one lost. So that's why we're setting that game object that fell through back to the head position, and we're resetting its velocity and its angular velocity on its rigid body to 0, so that it's not still being pushed around or falling or rolling. Now let's work on the check ball method, where almost all of these other methods are going to be called or not. So if the ball that is being checked, which remember, check ball gets called when a ball enters the collider, so goes through a hole. If the ball is the cue ball, we're going to do something. Otherwise, if the ball is the 8 ball, we are going to do something else. And then else, the only other option is that if it's not the 8 ball and it's not the cue ball, then it's going to be either a red ball or it's going to be a blue ball. So those are our 3 conditions that we need to check when a ball goes in. So let's handle if it's the cue ball first, which is going to require calling the scratch method. Just make sure this is all good. Everything looks all right. No errors, at least. So if scratch returns true, then check ball is going to return true. Otherwise, check ball is going to return false. Now this is because scratch returns true if someone lost and returns false if it was just a normal scratch and no one loses. And when we check for our collisions, if true gets returned, it is going to just destroy the ball. So that would be if someone lost. False is going to be if it was a normal scratch and it moves back to the default cue ball position. So the 8 ball, we are going to do if the current player is the current player.player1, then we're going to check to see if it was the winning shot for them when that 8 ball went in. And if it was, then we're going to trigger the win condition for player 1 and return true. Otherwise, again, the only other condition is that it's player 2's turn. So we don't have to specifically mention that in the else statement. We'll check to see if this was the winning shot for player 2. And if it was, we will trigger the win condition by calling the win method with player 2 passed in as an argument, and we will return true. And again, we're returning true because in the method that called check ball, if true gets returned, it's telling it that it's okay to delete the ball that fell through the hole. And we can see this early 8 ball is what we need to call if someone didn't win. That means they hit the 8 ball in early and they automatically lose. And here we need to put all the other logic for if it's a blue ball, a red ball, whose turn was it? Was it the last one? Was it not? So let's say if the ball that got knocked in is red, and we'll get that by calling its isBallRed method, which returns a true or false. So if it returns true, that was a player 1 ball, because player 1's balls are the red ones. So we're going to subtract 1 from player 1 balls remaining. Then we're going to check to see if it's less than or equal to 0. If the player 1 balls remaining is less than or equal to 0, we are going to set is winning shot for player 1 to true. And then we're going to check to see if the current player is not player 1. That means player 2 knocked in a red ball. It would then go to the next player's turn, which would then go to player 1's turn. So the other and the only other condition, because it's not a cue ball, it's not the 8 ball, it's not a red ball, so it's a blue ball. So player 2's ball remaining are going to go down by 1. If the player 2 balls remaining is less than or equal to 0, then we are going to set is winning shot for player 2 to true. And then we're going to check to see if the current player is not player 2, meaning player 1 hit in a player 2 ball, then we're going to call next player turn so that it will then go to player 2's turn. Now, before we jump back into the editor, just remember we have these, UI references and the button and the head position references that we need to pass in. If we forget to do that, we'll hit some errors. So let's just double check the ball prefab has that ball tag. Let's make sure we've got all of our UI elements on the canvas. Let's go ahead and add that button. So UI button. Let's rename it to restart button. Set this to isometric. Hover over the canvas and then hit F. And let's just make sure, let's turn this back to active so that we can position these in a way that the text isn't going to cover up the button or vice versa. So just go ahead and set the text in here to play again and kind of move the button around. Let's make it a little bit bigger, maybe 200 for the width, 100 for the height. That looks a little weird, but let's make the text bigger. Let's select the text, set it to 35. I don't want it to be on 2 lines. So let's adjust it, set the height to 75. That looks pretty good. And now we need to make this restart button do something when you click on it. So you can see that it has this button component over here. Let's also make it disabled at the game start, so that it's not showing when the game starts. And let's go ahead and link all these up before we forget. So player 1 ball text, player 2 ball text. We're just dragging and dropping these down from the inspector into the game manager in their appropriate slot. So the message text, let's make sure we disable that so we don't forget. And let's come back to this game manager and get the restart button in there, and then this head position, which remember is the cue ball position. So let's open up the Mesa game object. There's the cue ball position. Let's drag that in there. Okay, now let's get the on-click method for that button working. So how these work is that you can add something like a method or whatever to be called when this button's on-click event is fired. So when someone clicks on the button, it will fire the on-click event, and you can choose what happens in response to that on-click event being fired. So we're gonna add a new reaction to this event, and we will be able to choose which object from our scene is going to be the thing that is going to respond. So let's click the little plus button here, and we want the game manager to be the thing that does something in response. Because remember, this is where we're referencing that restart button. And in fact, let's go to the game manager script and make a public void restart the game. Has to be public because it's going to be called from that button. So to do this, let's just reload the scene. So we'll do scene manager dot load scene, and we'll put 0, and we'll configure that to make it so that works. So let's go back to Unity, and let's just get this set up first. Let's drag the game manager over here to the on click, go to this no function dropdown, go to the game manager, and find restart the game. So that is the method that is going to be called in response to this on click being fired. So let's go to File, Build Settings, and up here, Scenes in Build. We click Add Open Scene. You can see the index is 0. That's the scene we're in right now. And that's what that means in the code when we say scene manager.load scene 0. We only have one scene. It's this one. It's the gameplay scene. So when the game is restarted, actually all it's doing is just completely reloading the scene. And before I forget, when we were scrolling around down here, I noticed something that bothers me. I forgot the space right here for player 1. Oh, and look, here's a bug. This should be, if it was player 1's turn, switch to player 2, otherwise switch to player 1. I accidentally put switch to player 2, so that would have made it really weird on switching turns. Also, we never actually updated the text for how many balls each player has remaining. We updated the count, but we didn't actually update the UI. So down here in our check ball method, right here where it says, if the ball's red, subtract. We're going to do player1 balls text.text. I got to go back. Okay, it's player1 balls remaining, colon. I'm just going to copy that. And we can just paste that in here. Except instead of 7, we are going to keep the space there and add or concatenate these two. So it's a string and an integer together, and it's just automatically going to convert the whole thing into a string. And we will do the same down here for when player 2 loses a ball, and just make sure we set that to player 2 balls text, player 2 balls remaining, plus player 2 balls remaining. Now, before we test everything that we just wrote, let's go back to our ball prefab. And remember, we had locked the, frozen the Y position earlier so that it didn't fly off the table. But if Y's frozen, that means it won't actually be able to fall into the holes either. So let's unfreeze that. Let's play. And let's just grab a red ball and drop it in. And hey, look, it updated. It didn't switch to player 2's turn. Let's drop in a blue ball, and it did now correctly switch to player 2's turn. Another blue ball shouldn't, nope. So it doesn't change whose turn it is. Player 2 hits in a red ball, it switches back to player 1. So now it's player 1's turn. Let's see if so player 1 hit in the white ball, and it goes to player 2's turn. Because if you scratch, it goes to the next player's turn. So player 2 hit in the white ball, so now it's player 1 turns again. Player 1 hits in the cue ball, and now he has lost. Or sorry, hit in the 8 ball, not the cue ball. So that works. Let's play it again and just kind of test some of our other conditions. Okay, so player 1 scratches, it goes to player 2's turn. Player 2 hits in the 8 ball, and player 2 has lost. So the play again button works. So player 1, let's just start dropping in red balls. Player 1's doing really good. And let's just see what happens when they have no balls left. If they knock in the 8 ball, they should win. Yep. So player 1 is won. Let's hit play again. And we still have not checked the condition where player 1 is, or player 2, is on that final shot, but instead of hitting in the 8 ball, they scratch. Normally a scratch doesn't lose, but when you're on your final shot, you do, and we can see that works. All right, let's exit play mode. What we have to do next is going to be pretty frustrating because of what I mentioned earlier. We want this, pool stick to be shown like kind of a first-person view, like under the camera, but it's not a separate model from the ones on the wall. So, unfortunately, what that means is that we're just going to move all of them at once. And it shouldn't really be a big deal because the ones that are like floating off to the side are going to be outside of the view. Like the camera won't be able to see them, so it doesn't matter. So you can see this this stick is a single stick, but it has that X thing on the tip, so I don't want to use that one. So basically what we need to do here is we want to get the camera positioned in a way that looks good, where you can see the stick and it's lined up with the ball in a good way, and it has a nice straight path so the players, they know what direction they're hitting in. And I think the easiest thing to do is to make these sticks a child of the camera. And so when the player's aiming or whatever, it's moving the camera and the stick moves with it. So I'm just trying to set this up. The rotation, yeah, so like rotating those sticks just does some kind of crazy stuff. I was trying to make this one lined up better that's on the table because it looks a little tilted. But their pivot point is so messed up that they're all just moving all over the place. So I think the best thing to do is going to be just try to move the main camera into position and try to get that to look good. And then from there, we'll see what we can do. So I'm still kind of messing with the rotation on this before we jump straight to moving the camera around. I just want it to be lined up well. And I really wish this was just a single model with the pivot point placed correctly. There are ways around the pivot point being in a weird spot. You could make a empty game object, put it where you want the pivot point to be, and then make that thing a child. I really wish we could use this single model here, but that X on the tip just, doesn't even make any sense. So I don't know. I'm not a pool player. Maybe there's a point for that. I thought it was like a rest where you put the ball on top of the rest, but that's not what it looks like. It's like actually the X is on top of the tip, which doesn't make any sense to me, but whatever. So let's just grab this main camera here over in the hierarchy, switch to side views or whatever view we need. I'm going to switch to this isometric, and I think this is going to help me line this up. So I'm looking straight down the back of that stick in this isometric view. So, and it actually looks pretty straight. It might have just been the perspective that was making it look a little tilted. But that doesn't look tilted to me. So I'm going to grab the camera and just move it right above the stick and move it closer. It's really far out. Let's put it at 0 on the Z. Okay. It's facing the wrong way. It's facing towards the back. And you can see that now when we move the view. So let's rotate the camera so that it is actually facing the other direction. So we'll rotate it 180 degrees on the y-axis. Now let's move it back. Try to get it, where we think is good. That looks okay. All right. That looks like it's lined up with the camera straight. Just kind of make this look how you want it. So I'm just messing with the field of view here. I think 60 looks fine. But whatever you think looks best, move it around. This doesn't have to be exactly the way I do it. It's still going to work. If you think there's a better angle for the camera that looks, more natural, or it's easier to aim, or looks more real or whatever, just experiment. Rotate the camera, move it around, and just try to get something that you think works. So I kind of like how I have it right here. I like how that looks. I tried tilting my camera down, but I undid that. So its rotation is just 0, 180, 0. And then the position is just based on how I moved it right over this pool stick. So I'm pretty happy with that. And I think that's how I'm going to keep it. Let's drag a ball out here on the table and, try to line it up and see what it actually looks like for the player when they're looking down this stick. Okay, so yeah, that doesn't look very good. That's why. It's quite a bit higher. So I'm just gonna adjust the ball to be resting as close as I can right now onto the table, because that's what it's actually going to look like with the real balls. That looks really good right there. And then I'm just going to keep moving around the pool stick and the camera, combination of both of them, and just get it to where it looks good. So you can see as I'm moving them, I'm making sure I select the camera and then control clicking on the stick and moving them both together. So I'm actually quite happy with how that looks. So let's create a new script for this, like for the camera, I guess. So let's go to our scripts folder, right click, create C# script, and I'm just going to call it camera controller. And this is going to be what we use to aim and shoot. So I'm just going to select the main camera, drag and drop the camera controller script over there. And let's also take all the sticks, which are in this tacos thing. Let's drag it out of the main prefab, like the pool hall prefab, and make it a child of the main camera. And now, as the main camera moves and rotates, the stick will do that as well. So here you can see I'm just dragging it and rotating it, and the stick is moving with the camera. So I do notice that issue with it clipping through the sides, which is going to be pretty annoying when you're shooting if it's not lined up in a perfect position like it is right now, where it's not clipping through something. So obviously when the player's playing, we don't know what angle they're going to be shooting from, so we'll have to fix that. But for right now, let's open up the camera controller and let's define a transform cue ball, and that's just going to be like the location of where the cue ball is. Let's make a serialized field, a float called rotation speed, which is going to be like the sensitivity of the mouse when we're aiming. And let's also do serialized field float offset, which is going to be the distance from the cue ball that we want the camera to be. And serialized field float down angle, just because we want to fix that clipping issue. So we know that it's going to have to be tilted up somehow, but I'd like to make it a serialized field so we can mess around with it in the inspector. Let's let's do a private float horizontal input, and that is going to be used later to get the input information from the mouse to rotate the camera. So let's give it a public void reset camera. And what this is going to do is we want it to reset the camera's position back to the cue ball's position plus this offset. Okay. Oh, yeah. Okay. Let's make offset a vector 3, and that'll work. And we also want to call transform.lookAt, which takes a position and it makes this game object's forward axis, which in this case is the z-axis. Its local z-axis is forward. It makes that look at the position that you pass in. So it's going to look at the cue ball. And then it's going to set the local rotation of the camera to the down angle rotation on the X, the just keep the Y what it was, and 0 on the Z. So right here in start, let's do for each game object ball in game object dot find game objects with tag ball. So what this is saying is for every single game object that you can find that has the tag ball, which is going to be all the balls that are in the scene, it's going to check each one. It's going to say if the ball script that's on the ball that's currently being checked returns true, that it is the cue ball, then we will set the cue ball reference in our script to be the location of that specific ball, which is the cue ball. And then we will break out of that loop because there's no reason to keep going once we find the cue ball. And after that, we're going to reset the camera so that it is in the proper position based on where that cue ball was. So here in update, we're going to say if the cue ball transform location is not null, then we are going to update horizontal input to be equal to input.getAxis mouse x, which is between -1 and 1 as the player moves their mouse left and right. And then we're going to multiply that by rotation speed, which is going to be the sensitivity. And then we're going to multiply that by time.tilde_time so that the sensitivity number is actually going to be translated directly to degrees per second for the sensitivity. And then right after that, we are actually going to use this rotate around method. So transform.rotate around, and it's going to take a position to rotate around as the first argument. The second one is going to take a axis to do it on. So we want to do it on the y-axis, which is the same as saying vector3.up, which is the same thing as saying new vector3 0 1 0. And then the last thing is how much we want it to rotate, which we want it to rotate by an amount equal to horizontal input. Now, one thing we have to be careful of, up here in start, where we are looking for the cue ball, well, remember, the balls are getting spawned procedurally here in game setup. And what would happen if our camera controller started looking for the cue ball before it had actually been spawned? it might not get a reference to the cue ball at all because it wouldn't exist. And then is our game going to crash? Where's the camera going to be? We don't really know. So we want to make sure that the balls get spawned first. So here in game setup, let's add private void awake. And awake is called before start. So start is called before the first frame update. Well, awake is called even before that. So we actually want to do all of our game setup in awake. That will ensure that when the camera controller in its start method goes to look for the cue ball will definitely exist. Let's hop back into the editor, select our camera, and adjust some of these new variables we gave it. So I'm going to put the rotation speed at 360. I'm going to put the offset, let's say 1.5, Y 0.5, and the down angle 10. Let's hit play and see what this looks like. So we've still got that clipping issue. So let's move the offset to, I thought 1.5 was good, but the Y, let's do 0.08. And let's change the down angle to 15. Okay, let's change the offset to 1.2. Hit play again. Okay, now that looks good. I didn't see any clipping, but it needs to be way more sensitive. So I'm just going to multiply that 360 by 4. So now the rotation speed's 1440. That feels way better. Okay, I like those settings. And I still haven't seen any clipping from the stick. Cool. Let's go in and back to the camera controller, and let's write some temporary way to force the camera to reset. So I'm just going to put this in this comment here so we remember to take this out. Okay, so let's just say if input.getKeyDown keycode dot space. So if you press the space bar on the frame, you press it, we're going to reset the camera. So remember, resetting the camera should take the stick to wherever the cue ball is, and apply the offset as well. So let's just manually go into the scene view and move this cue ball. Okay, so, oh, yep. And then we hit spacebar to reset it, and it did. It found the cue ball, and it has moved the stick in the camera there. Let's just, okay, so it went in the hole. We'll go back, hit spacebar. Yep. And we're back on the cue ball. So that works. And now that we have a temporary way to reset the stick, let's go back into our camera controller and let's write a temporary form of actually, hitting the cue ball. So let's serialize field float power up at the top, so that we can, in the inspector, adjust how hard we're hitting the cue ball. So let's do if input.getButtonDown fire 1, and we're putting that inside the update method, so it's called every frame. Then we are going to define a new vector 3 called hit direction, which is going to be equal to transform.forward. So that's saying take the vector that the camera's facing, because we're talking about the transform on the game object this script is on, which is the camera. And then we're going to adjust hit direction to be a new vector 3 that takes only the X from where the camera's looking and the Z from where the camera's looking, but it ignores the Y and just sets it to Z. So if our camera's tilted, which it is a little bit, that will ignore that. And we're going to normalize it so we get rid of any distance and just make it a direction. Then we are going to, so cue balls just to transform. So we're going to say cue ball dot game object, which gets a reference to the game object that the transform's attached to. And then we're going to get its rigid body component, call the add force method, and we're going to put in the hit direction and then multiply that by the power and make sure we do force mode dot impulse so that it applies all of the force instantaneously in that one frame. So let's hop back into the editor here and let's try it out. So main camera, let's make sure we actually give it a power value. Let's say 5, hit play, and let's see if this is too strong or not strong enough. So we're going to aim, click. So that was like a max power shot. So a couple problems. It didn't hit them that hard, and the balls also are just going to roll or rotate forever, it looks like, some of them. So let's stop playing and try to figure some stuff out here. So back in the camera controller, let's add a debug.break right under where the force is applied. So remember, as soon as that force is applied, it's going to pause in the editor. So right when we left click, look, it paused. So now we can zoom in here and just step frame by frame and kind of watch what's happening here. So there it kind of made contact. Let's unpause. And things just kind of, looks like they're on ice. They just kind of keep floating away. So, but at least that's working. But we need to fix those physics. So let's, down here in the assets, let's right click, create a new folder, physics materials, right click, go to create, physic material. So let's call that ball. Let's right click, create, physics material. We'll do another one and call it table. So now we can apply these physics materials to the ball and the table. Notice they have a dynamic and a static friction and a bounciness, and how to combine the friction or the bounce between two different physics objects. So now we're just going to kind of mess with these friction settings to get our balls to behave a little bit better. So let's go to our prefab folder here, select our ball, and you can see over in the inspector, in the sphere collider, there is a spot for physics material. So if we click on our physics material, we can just drag the ball physics material to the ball. And we also have to make sure that our table has the table material on it as well. So let's, over here in the hierarchy, let's go back to the Mesa parent, and remember, we've got all those walls and the 3 floor. So let's just select the 3 floors, and luckily you can drag it over there, and that set it to all 3 of them at once. So we can also grab all of the wall objects, which I believe goes from cube down to cube 1. So let's go ahead and select cube. I'll just run through them all with the arrow keys real quick. Okay, yep, it's cube through cube 1, so click on cube, shift click on cube 1, select them all, and we're going to drag that table material over there in the box collider. So now the tabletop and all the edges have that table physics material, and our ball prefab has the ball physics material. So in our ball prefab here, let's set the mass to 0.17, which is the actual mass in kilograms of a pool ball. Now, because the scale has been kind of weird, like remember things were like scaled up by 100, it might cause some issues with using like real world weight of the pool balls, but let's give it a try. So let's select this ball physics material and give it a dynamic friction of 0.2 and a static friction of 0.4. So the static friction is how much friction it needs to overcome to start moving, and the dynamic friction is the friction when it's already moving. So let's actually change static to 0.35. And bounciness, let's try 0.15. Let's go to the table and let's set the dynamic friction and the static friction to be the same. So 0.35 for the static friction and 0.2 on the dynamic, which are the same as they are on the ball. And the bounciness, let's just leave that at 0. Okay, let's hit play. So remember, we changed all the physics materials, which is going to change the friction and stuff, but we also made the ball way lighter. So let's see what happens. So remember, I shot. We still have that debug.break right there. So let's get rid of that, since we've verified that it actually is shooting the ball correctly and it's not bouncing up or anything like that. So, okay, well, that didn't work. That just launched the cue ball way off the table. And when I tried to reset it, it just kind of went crazy. So let's change the power on the main camera from 5 to 0.5. Let's hit play. Okay. It still doesn't look like it's hitting super hard. And some of the balls look like they're just like, once they get moving, they'll like never stop. But a lot of the ones in the middle looked like they started to move a little bit, and they definitely did stop. Or at least, well, they're like still rotating, and you can see they're all still kind of moving. So let's adjust our friction on the ball to 0.4 and the static friction to 0.7. And I'm going to do the same here on the table. So 0.4 for the dynamic and 0.7 for the static. And let's try that again. Okay, that's definitely not going to work. Nothing moved. So that must be way too much friction. But it's weird. It's like if a ball gets moving a certain speed, it just keeps going and never stops. So maybe it's too much friction. We're requiring too much friction to get them moving, but not enough to stop them once they're going. So let's flip dynamic to 0.5 on the ball and static to like 0.4. So now the dynamic friction is more than the static. That didn't really change anything, did it? Okay, so let's just keep working with these physics materials. Let me see if I change it while the ball's rolling, if it stops. Nope. Even at 1. So that either means that's not the problem, or those just don't update while the game's running. So let's set it to 1, stop play, start again. Okay. So did you see how it like went really fast and then it like got to a certain point and it just slowed down a ton? I suspect what's happening is the friction is like slowing it to a certain point, but then after that, the friction's not enough to stop it. So I think it's this drag. So let's select the ball prefab and set its drag to 0.1. And maybe now it will kind of slow down on its own. Okay. Well, very slowly, but it kind of looks like they're slowing down. Let's stop playing and set the drag to 0.2. See what that looks like. So the middle ones are not moving or are kind of moving. Okay, they're not. So some of them did stop. Let's go back to the table physics material and set it to 0.2 for static, and same with the ball. And let's see what happens now. Okay, so those were stopping. They're just not stopping super fast. So let's go back to the ball prefab and set the drag to 0.5, which is the highest setting that we've had it. So okay, I feel like it just keeps getting better and better. It's still not hitting the balls with much force to like spread them a lot, but they're at least slowing down and stopping. Let's set the power on the main camera to 3. Actually 2. Let's set it to 2. And just get a little more power here in our hits. Okay. So it definitely had more power in the hit, and the balls are actually stopping. So oh, look, that one's like was just rotating in place. So we'll have to take care of that, which, because they're spheres, even though they're not like sliding across the ground, if they just rotate forever, there's, it might move. It's definitely going to cause issues. It should stop rotating and stop moving. I'm sure you saw the cue ball just fly off the table again just then. So let's open up the ball script, and in fixed update, which is called every physics step, not every frame. So depending on what your physics engine settings are for your particular project, it could either be faster or slower, like per second, than your frame rate. So let's add a new reference to a rigid body up at the top. And in start, let's just set that to be the get component rigid body on this game object on the ball. And then in fixed update, we're going to say if the rigid body dot velocity dot y is greater than 0, set rigid body dot velocity dot y to 0. Okay, we can't directly set that. So let's try something else. Let's try rigid body. No. How about vector 3 new velocity is equal to the rigid body velocity, and then we'll set just the y of that to 0, and then we will set the rigid body dot velocity to new velocity. So that way it retains its x and z velocity, but if its y velocity, which would be leaving the table, is greater than 0, it will set it to 0. So that should stop, hopefully, balls from flying off the table. Okay, so that ball didn't look like it went up. It looks like it actually just went straight through the collider wall. So let's go to the ball prefab. And here in rigid body, we have different collision detection modes. So discrete doesn't check as often as like continuous does. So let's set it to continuous. Try to get the ball that close to the wall again and shoot it at, right at the wall and see if it bounces off this time or if it goes through. Okay, so that actually looked like it bounced off the table. That didn't look to me like it went through the collider box. Now that time definitely didn't go through the collider box, where earlier when we shot it that close at the wall, it just went straight through. So it looks like the continuous collision is definitely helping. Let's try another. Okay, so that that cue ball just went through that red ball. So basically what's happening is the ball is moving further in. It's like it's in front of like the red ball on one physics step, but it's moving so far per physics step that on the next physics step, it's actually moved so far that on the very next step, it's past the red ball or past the wall. That's why stuff like that's happening. So let's go back to the ball prefab, and there's a couple things we can try. Let's set interpolate to interpolate, and let's set the collision detection to continuous dynamic, which is the most demanding, but the most accurate. And by setting the interpolation to interpolation, it will kind of do a little bit of math on like where it's going to be, where it should have been, like, oh, I'm going this direction this fast. There's this thing this far in front of me or whatever. I should hit it. And then so it can kind of make a little adjustments to what actually collides and happens and try to fix some of those issues. So, I mean, so far, that looks like it solved our problems, at least for now. it still doesn't look right. So let's go to the ball prefab and set the drag to 0.6. I feel like the collision's working now, but like the drag and the friction, the balls just aren't moving how I think they should. So again, at least they're stopping. I'm going to adjust the ball physics dynamic friction to 0.4. No, let's try 0.3. And then the static friction 0.4. And the table, I'm going to do 0.3 for dynamic and 0.4 for static. Let's hit play. So I mean, they are stopping, but let's change the table to 4 dynamic, 5 static, and do the same with the ball, or 0.4 and 0.5, sorry. Let's hit play. It's getting better slowly. This is just a lot of trial and error to like find that perfect number where they're not going to stop too fast, but they're not going to like take too long to stop as well. I am going to just keep making changes. You can skip ahead a little bit. I'll say something once I either give up or get some numbers that work better. So it still is just really weird. I'm going to let's go to the ball script and yeah, I commented that out to see if that was the problem, but it wasn't. So let's just come back to the physics. Feel free to tweak it as much as you want. I mean, the most important thing is that it looks good to you. So if you find the magic numbers, please let me know in the comments. So let's add a second camera. So in the hierarchy, we're going to right click, create camera. Let's call this one overhead cam. And what I want to do is after a player has hit the cue ball, the camera changes from the one behind the stick to one up above the table, looking straight down at the table. So let's just set the position to 0 on the X, 0 on the Z, so it's right over the center of the table. We can go into the game view so we can see exactly what the camera sees. Let's kind of adjust the Y. Okay, 2.5. All right, so we're seeing these lights but we kind of need to be this high to see the whole table. So what we can do is, let's just worry about getting it high enough first. Okay, 3.2, 3.5, 3.4. Down here in clipping planes for the camera, you can change this number, and the higher you make it, that's a distance from the lens that'll just ignore anything. So it's completely ignoring those lights. So even though the camera's above those lights, it's not actually rendering those lights. I'm also going to flip this camera on the y-axis 180 degrees, just because I want the cue ball's default position to be at the bottom. So that looks good. We are going to have some references to these two cameras in our game manager so that we can switch between them. So let's go to our game manager script and let's make that happen. So here we are. Let's just up here at the top, add another serialized field. This is going to be a camera, and let's call this one cue stick camera. And the other one is going to be our overhead camera. So let's do camera, overhead camera. Okay, great. So there's a reference to our two cameras. And now we need to switch between these cameras. So I'm also going to do current camera, so that we can keep track of what the current camera is. So when the game first starts, here in the start method, we want the current camera to be the cue stick camera. Right when the game starts, that's going to be the main camera that player one is looking through. So here underneath update, let's do public void switch cameras. And we're going to say if the current camera is equal to the cue stick camera, well, then we want to disable the cue stick camera and enable the overhead camera. And we want to make sure that we set the current camera to the overhead camera. Otherwise, meaning the only other condition is that the current camera was the overhead camera, we want to enable the cue stick camera, and then we want to disable the overhead camera using overhead camera.enabled equals false, and current camera equals the cue stick camera. So that is how we're going to swap cameras. If you have multiple cameras in the scene, the one that it's going to render through is the one that's enabled. So you pretty much disable every camera that you don't want to use and enable the one that you want. And that's how we switch them around. So one situation we know that we want the cameras to swap is when the cue balls hit. So let's go to the camera controller, and we're going to need a few things in here to make this happen. So first off, we are going to need a reference to the game manager. So let's just set it right here in the start method. We're going to do game manager equals game object dot find game object with tag, and game manager dot get component and the game manager script that's attached to that game object is what we actually want. And it looks like it's not tagged. So let's make sure the game manager is tagged, and it's actually the default game controller. So let's change that to game controller. Now, as soon as the camera controller enters the world, it is going to grab a reference to the game controller. So we know down here where we are doing this if input.getButtonDown fire, this is also where we want to swap the cameras. So game manager.switch cameras. We made that switch cameras method public, so we can call it from this other class. So let's hit play and let's see if that works. Okay, so it's not because we forgot to drag the two cameras into the game manager. So let's drag the main camera in there, and let's drag the overhead camera in there onto the game manager, and also both are active. So let's go to the overhead cam and turn it off. Now when we hit play and we shoot, it automatically switches to the overhead camera. So even if you have everything linked up, you need to make sure that in your hierarchy over there, that the overhead cam, that its camera component is disabled. It's just a little check mark. See, right over there, right at the top. We also got some error about multiple audio listeners. So main camera or overhead, just turn one of them off. Let's go back into the camera controller here and add a new condition for firing. And so in the line where we fire, let's put and game object dot get component camera dot enabled. So you can only shoot if the main camera is enabled. So only if the Q stick camera, or whatever we want to call it, is enabled can we shoot. Up at the top, we're going to add a new serialized field. It'll be a game object, and it'll be the Q stick itself. Because I also think after you shoot, the Q stick should become invisible. So right here in the area where we're shooting, we are going to set active on the Q stick, call that method, and pass in false. That will make the Q stick invisible. And we also want to make sure that it is visible again. So in reset camera, we will set qstick.setActive to true. So now let's test it, hit play. Wait, something. Oh, I forgot to drag the Q stick child into the main camera's new reference that we just made. Now let's hit play. Okay. When you shoot it, it goes to the overhead camera and the Q stick disappears. Great. That's exactly what we wanted. And it works. And I hit spacebar to force that reset, and now the stick appears again. So that is working just as we wanted it. Let's go to the game manager now, and I want to make sure that it can't switch to the other player's turn unless all the balls on the table have stopped moving. So let's add a Boolean up here. I'm going to call it is waiting for ball movement to stop, and set that to false. So all that's going to do is I'm going to use that for after someone's hit and it's in that time period where it's still waiting. That's what that Boolean is going to be. So here in update, we're going to have a condition if is waiting for ball movement to stop is true. And then inside of here is where we're going to have to put all the logic to check if the balls are moving. And then also when all the balls have stopped moving, it can move to the next person's turn. Let's head down to the switch cameras method inside the game manager script still. And when it switches from the overhead camera back to the cue stick camera, we should reset the cue stick to go to where the cue ball is and become visible again. So we're going to call current camera.gameObject.getComponent camera controller.reset camera. So that will call this reset camera method in the camera controller. We can get rid of that temporary restart that we had in update and only rely on the method down at the bottom now. You can see when the camera's reset, it's going to set the cue stick back to active and reset the position and everything. So let's go back to the game manager script here. And right now we need to find all the places where either it's going to flip on, is waiting for balls to stop moving, or moving turns. So we want to replace these with something else because we do not want it to switch turns until all the balls have stopped moving. So here in Scratch, we can see it is calling next player turn. Let's comment that out and instead set is waiting for ball movement to stop to true. So this would be the condition where one player hits in the cue ball and it wasn't their last shot, meaning they have balls on the table. It's not just the 8 ball left for them. And instead of immediately progressing to the next player's turn, like before, it's going to set that is waiting for balls to stop moving to true. So we have it here as well in the, if a red ball gets hit in and it wasn't player 1's turn, it was going to automatically go. Well, now it's not. It's going to set is waiting for ball movement to stop to true. And now we know it's not called anywhere else because the method name down here for next player turn is kind of dimmer or darker than the other ones. So that's good. We wanted everywhere that it was being called from to not call it anymore because we only want it to be called after all the balls have stopped moving. Now, another thing that we can do is, well, we know when it switches people's turns, it also needs to switch cameras. So we can come down here into the next player turn method and we can put right here at the end of it, switch cameras. So it doesn't really matter whose turn it sets it to. No matter what, at the end of that method, it's going to call the switch cameras method. Well, another place we know that it needs to be waiting for all the balls to stop moving is right when it switches from the cue stick camera to the overhead, because that means a ball had just been hit. So here in switch cameras, in the top condition, from switching from cue stick to overhead, we're going to set is waiting for ball movement equal to true. Let's do a little more cleanup here in the game manager to account for some, I don't want to call them edge cases, but other things that could happen. I'm going to make a Boolean up here called is game over and set that to false. Obviously, because when the game first starts, the game's not over. So here in update, let's have it in addition to seeing if it's waiting for ball movement to stop and not is game over. Actually, I'm going to erase that for now, and we might do it a different way. Let's go down here. So this no more balls is never getting called, so let's just delete that whole method. And let's just comb through, make sure that we don't have any other unused methods, make sure that we're not calling anything in the wrong place, or that we forgot to call a method in a place that it needs to be called or whatever. I don't think we need this is waiting for ball moving to stop equals true here in the scratch method anymore. Okay, I'm going to go through now again, and anywhere that got affected by this is game over needs to be checked. So all those are good. Okay, so the lose method, of course, is game over, needs to be set to true. And of course, in the win method, we also need to set is game over to true. Okay, let's go back up to the top, and we're going to add a new Boolean called will swap players and set that to equal false. And this is a Boolean that's going to get turned on when the condition has been made that players need to be swapped. So let's go down here to the checkball method, where we have this section where either a red ball or a blue ball got hit in, and it's not the cue ball or the 8 ball. I'm having to type these in. I accidentally deleted these earlier and forgot to record it, so you guys should already have this. The only thing that's going to change is you need to add inside that check will swap players equals true. Inside the if current player does not equal current player dot one, and lower down inside the if current player does not equal current player dot two, you need to put it in there as well. Let's go down to the next player turn method right here. And we are going to have to, outside of the if and else statement, we will put will swap players equals false. And this is essentially resetting it back to the default value of false after it's already decided to swap players. So let's take care of this is waiting for ball movement to stop. Let's go ahead and add back this and not is game over. I decided to do it this way after all. So let's add a Boolean called all stopped and set it to true. And then we're going to do for each game object ball in find, why isn't this showing up? Oh, yeah, game object dot find objects with tag ball. So we're going to look through every single ball that's in the scene one at a time, and we're going to access that rigid body with ball.getComponent rigidbody.velocity.magnitude, and we're going to say if that ball's magnitude is greater than 0, sorry, the magnitude of its velocity is greater than 0, then it's false that they've all stopped. We're going to break out of the loop because there's no point in checking anymore. And then after that, we're going to check to see if all of them have stopped. Then we're going to set is waiting for ball movement to stop to false. And then we're going to check if players should be swapped. And if they should be, we're going to call next player turn. And if they shouldn't be, we're just going to switch cameras. But it will not swap turns. So I want there to be some sort of timer involved before it starts searching to see if the balls aren't moving. So let's add a serialized field float called shot timer. And I'll just put it to 3 as a default, 3 seconds. And a private float, which is current timer. So the current timer is going to be what we use to count, and the shot timer is going to be what we use to reset it. So in start, we're going to set current timer to shot timer. And then inside the update method, inside of that if statement, checking to see if we're waiting for the ball movement and the game has not ended, we're going to add current timer minus equals time.delta time so that every single frame, it's going to subtract from that timer the amount of time between this frame and the last one, which ends up subtracting 1 every second. If the current timer is greater than 0, we're just going to break out of this, which means we're not even going to check to see if all the balls have stopped moving. And at the bottom, when we finally do have our condition where they have all stopped, we are going to set the current timer back to being equals to the shot timer. Let's go back to the top. Let's add a serialized field float called movement threshold. Just because I think saying if the velocity dot magnitude is greater than 0 is kind of a little unsafe. We should make it if it's less than or equal to the movement threshold. So now if it's going really, really, really slow, we can still, consider that stopped. So let's go back to the editor. Let's select our ball prefab, and I'm going to give it an angular drag of 0.6. So that should stop some of the crazy rotating that it had. And in our game manager, I'm going to set the movement threshold to 0.000001. And let's test it out. So I'm going to play, and okay, that didn't look great. In the game manager, I'm going to set the movement threshold to 0. Tons of zeros. 1e negative 1.6. So now, if it's at that or lower, it's going to consider them stopped. Okay, so it's definitely progressing to the next, camera swap when they haven't fully stopped moving. So something's wrong. So let's go back into our game manager script and see if we can find what the problem is. Let's check out our line here where we're checking the movement threshold. So under this, let's add a debug.log and let's debug the rigid body components magnitude of the velocity of anything that's above that threshold. So let's hop back in, hit play, and let's try. Okay. I think I know what the problem is. All right, let's go back to the game manager. we actually want, instead of saying velocity.magnitude is less than or equal to movement threshold, we want to change it to greater than or equal to movement threshold. Because we're checking to see if a ball's over the threshold, which is what's considered moving. So here we go. So the 3 seconds went by. We're getting a bunch of readouts for the velocities. And they're moving pretty slow at 0.002. So let's set that as our movement threshold. Let's play again. And as soon as they all drop under 0.002, bam, there we go. It considers them stopped, and it will switch from watching back to letting somebody hit a ball again. Okay, let's try one more hit here. Okay, our cue ball went off the table again. It's going to fall forever. It's never going to stop. So it is never going to progress to the next player's turn. So we need to make it so that if the cue ball does fly off the table, which looks like, despite our best efforts, that keeps happening, let's make this collider on the game manager just, well, not the collider actually, but the object itself, just huge. And so now if we knock a cue ball out, it's gonna still fall through the game manager's collider, and it will count as a scratch and move the cue ball back into the default position. Okay, I think I just saw something wrong. So we just scratched. I think it was player 1's turn. It should have gone to player 2's turn, but it didn't. So let me purposely try to scratch again. So it's player 1's turn now. I just scratched, and it did not go to player 2's turn. So let's go back to the game manager script, and we have to fix that. Okay, so I'm just going to go through every place where it should be setting will swap players to true. So down there in the check, that looked good. The update stuff looks good. Okay. All right. Yep. There it is in Scratch. So it's just not doing it in Scratch. Okay, there we go. If someone scratches and it wasn't their last shot, it will now set will swap players to true. Okay, one other big rule in pool that we haven't implemented is that if one player hits the cue ball and does not pocket any ball on the table, it will go to the next player's turn. So in the game manager, let's add a Boolean. I'm going to call it ball pocketed. We're going to set it to false. And then here inside of our update logic, on line 75, we're going to put or not ball pocketed as an additional condition to that if statement. So now if will swap players was true, or if no ball was pocketed, it's going to switch to the next player's turn. Also, at the very end, we're going to set ball pocketed to false because that's after everything has come to a stop. Now we need to actually find where we will set ball pocketed to true. So right here in onTriggerEnter, we already are checking to see if the thing that entered is a ball. So if it was, let's just say ball pocketed equals true. Let's hop back into the editor and enter play mode and test it out. Okay, so that worked. Player 1 scratched. And when it switched back to the stick camera, it was set to player 2. And just now, player 2 hit it and didn't knock in anything. And when it switched back to the stick camera, it had swapped back to player 1's turn. So I would say that's working. Okay, now we need a way for the player to actually choose how hard they're going to be hitting the ball. Right now, they just click and it shoots it with a set power. So let's go into our camera controller and add a private boolean, is taking shot, and set that to false. That way we can change some logic for how things work depending on if you're shooting or just aiming. Let's also add a serialized field float for max draw distance. This will be as far back as you can pull the stick. And a private float saved mouse position, which when they choose they're ready to shoot, we want to save that position. In update, we're going to add and is not taking shot to the aiming. So that means you can only aim if you're not taking a shot. Let's create a shoot method down here. And what we want to do is move all of our shooting logic, that's just an update, down into here. So the first thing we're going to do is check to see if the camera that this is attached to, which would be the stick, is enabled, which means that we're actually in shooting mode, not overhead camera mode. If that's true, then we're going to check to see if the fire 1 button is pressed, which is left mouse click by default, unless you've changed it in the input manager. We're also going to check to make sure that is taking shot is not true. So if that happens, you do press the fire button and is taking shot wasn't true. We're going to set is taking shot to true and save that mouse position as 0. So what this is basically saying is once you left click once, you enter shooting mode and you leave aiming mode. So else if is taking shot, we are going to check to make sure first that the saved mouse position, so 0, plus our mouse movement that we just did in the y-axis, so forward or back, is less than or equal to 0. We're pulling it back, so we want only negative numbers here. If it is, we are going to add that movement to 0, to that saved mouse position. And then that will change what saved mouse position is. So it's not going to be 0 anymore after that. Then we're going to check to see if that position is less than or equal to the max distance. And if it is, we are going to set the position to the max distance. And then outside of that if statement, we're going to have another one down here that is actually going to handle the firing. So if input.get button down, and you can see the only time it would make it down to this if statement was if you've already entered shooting mode. So actually there's no point in typing this out because all of the logic is right up here in our update method. So I'm just going to copy that, bring it down, paste it, get rid of all of our shooting logic from update, and instead, every single frame, we're just going to call shoot. Because we have all the if checks for did you click, are you in aiming mode, are you in shooting mode, are all in shoot. So we'll just call it every frame. And then we're just adding in here that is taking shot equals false. We're going to set that back to false as soon as you shoot. Now, the other thing that we're going to have to change is how our force is being applied. Before, we were just adding this power, and but now it's going to be a little more complicated. So hit direction is going to be the vector multiplied by the power. This time, we're going to multiply it by mathf.absolute, or abs, and then we're going to pass in there that saved mouse position, because remember, it's a negative. So this is now going to make it positive, and then it's going to apply that as an impulse force mode. So one other thing we're probably going to want is some type of UI indication so the player knows what their power is at. So let's add a serialized field. It's going to be text mesh pro UGUI. I called it power text. And we need to come down here and find out where we're going to update that and what we are going to set it to. So we want that to update once you've entered shooting mode and right after it's getting that mouse information and saving it to the saved mouse position. So we're going to do the power text, and we need to make sure that this is going to be between, 0 and 100%. So I think this is the lerp formula. I hope I get this right. It's saved mouse position minus 0. And then we're going to divide that by max draw distance minus saved mouse position. And the fact that it filled that in for me, no, I don't think that was 100% right. Yeah, so saved mouse position minus 0, all in parentheses, divided by, in parentheses, max draw distance minus 0, in parentheses, multiplied by, parentheses, 100 minus 0, in parentheses, plus 0. Okay, so it doesn't like that as of right now. I think that's for two reasons. One, it should be power text dot text, not just power text. But I'm just checking all my parentheses first. Let's go ahead and add that. All right, so it probably doesn't like the fact that that's a float, like being, yeah, it says cannot convert float to string. So I have another idea. Let's just, oh, okay. ToString doesn't work. Let's actually save this float like before we try to put it here. So we're going to do float power value number. I misspelled number, but whatever. equals, I'm just going to paste that there, delete it on the bottom line, and let's try to fix these parentheses. Okay, now it just doesn't like those last ones. So let's get rid of both of those. Okay, it looks like it's happy with that. Formula looks okay. So now we can just set it to that float.toString. And actually, maybe we could have done that before. Maybe my parentheses were just screwed up. It's very possible. So we are going to make sure to make the power text.text power and the colon and the space. And then we're going to add the power value. And then we're going to hit plus and then in quotes a % symbol. And that is what we want to show up. So let's go to our canvas. And we're going to have to add another text mesh pro object to our canvas. So we're going to go to canvas, right click, UI, text mesh pro. Let's change it to power colon, okay, 0. Bottom left, hold shift click, hold alt click, normally click. And then let's get our position offsets. So positive X is going to be 10 and positive Y is going to be 10. Okay, I like how that looks. I'll just preview it there in the game window. Okay, that should be fine. I'm just going to double check all my other UI stuff. Everything seemed to be working correctly so far. Okay, well, let's try it out. Okay, that's not going to work. We forgot to drag the text into its proper place in the main camera. I'm going to rename it power text and drag it down there. Now let's hit play. Okay, it definitely works. Sometimes there's a bunch of numbers after the decimal point, and when it's at 100, it doesn't show up all on the one line. So let's go back into the camera controller script, and we are going to make a few changes here. So let's, right under where we get the float for the correct number, let's do int power value int equals math f dot round to int and pass in the power value number. And then in power text.text, we are going to change what's displayed in between the text and the % symbol to be that new integer number. Now we get a nice rounded number between 1% and 100%. And it looks like it works just fine. The other thing we need to do is let's go back to our power text, and we need to just make this a little bit longer. So I just want to make sure that when it says 100%, or I don't know, if someone's screens looks a little bit different, I just want to give a little wiggle room there. So it's definitely going to show up perfect. That looks great. So that's all of our mechanics implemented. We haven't found any bugs yet, but that's every feature that this game is going to have. So the only thing left is fixing the physics. I don't like them. I'm going to set the rigid body on the ball prefab's mass to 1, and I'm going to change the friction for the ball and the table dynamic and static to 0.2, and I'm going to set the table's bounciness back to 0, and the ball's bounciness is 0.15. And I ended up with a power of 2 and a max draw distance of -5 on the main camera. And I'm going to go to Edit, Project Settings, Physics, and set the bounce threshold to 0.3. Physics, they look way better the lower that bounce threshold is, but if you get too low, it'll cause issues. So definitely feel free to experiment and keep making it lower and lower. Like I said, as you keep getting it lower, the physics are going to look better and better until something bad happens, which usually is things like bouncing even when they're sitting still. So just keep that in mind. But yeah, this is it. Tweak the physics, do whatever you want to do. As far as gameplay goes, this is it. We still have a little bit more to do, but it's not gameplay related, but it will put a little bit of polish on the game. So we still haven't used those textures that we imported earlier. We used the materials, but not the textures. So let's go back to this room here. And in fact, I'm going to duplicate this wall, drag it over here. I'm going to rotate it around the z-axis, 180 degrees. So now it's facing the interior of the room. And I'm going to use V, grab the vertex on the corner, and drag it and snap it to another vertex on the other wall. And now our room has 4 walls. So let's hit play and just double check. Yep, looks good. Nothing's clipping through the walls or any issues. And so it looks a lot nicer in here now. I encourage you to hit play and just play for a few minutes or more or whatever. Just try out all the different, combinations of, scratching, not hitting any balls in, hitting the 8-ball in too early, hitting the cue ball in when it's your last shot, when you're only supposed to hit the 8-ball in, and just make sure there are no bugs. But once you're done testing it out and you are convinced that it's good, let's do the textures. So let's do the floor first. So here's all of our textures in our texture folder. So let's click on our floor, and you can see over here it has this chow material. Well, a material is kind of what tells the graphics how to render it, but you can actually put textures, which are like photos, onto the material. So this dark wood diffuse goes in the albedo. The displacement images go in the height map. The normals go in the normal map, and the roughness ones go in the metallic. As you can see, you can change the base color to give it some tint. And right now it looks kind of really big. So here in tiling, you can adjust these numbers to make the texture appear bigger or smaller, and just kind of play around with those. You might have to do it on a per texture basis. One setting that works for one texture might not work for another one. So just kind of mess around with these and, get it to where you think the scale of that texture actually looks realistic. while I am playing around with this, I would just like to say, if this video has been helpful to you, please like and subscribe, and make sure you sign up for notifications so you don't miss any future videos. We'd really appreciate the subscriptions and the likes. And we hope that this has been educational and, if not, at least slightly entertaining. So you can see I had an error message over there that said, like, this texture is not set up as a normal map. Just click the little button next to it that says Fix Now. You can see I'm still trying to get this to look right. Every time I think it looks okay, I change my mind. Also, next to metallic, there's that smoothness slider. That affects how smooth the material is. So left is rough, right is super smooth, and that will affect how light reflects off of it. Not only how much, but like how sharp the specular reflections are. So let's switch to a wall. So you can see the wall is made up of, these three different materials. So this dark one is obviously the black down at the bottom. So you can see the materials down here in our material window. So I don't really know what texture is supposed to go on this, but I'm going to do this brushed concrete one. So this first picture is the diffuse or albedo. So we'll drag that into the albedo of this material. This is the normal. You can tell because it's always like purple. I'm going to click that Fix Now button. I'm going to take this displacement image and put it onto the height map spot. And then the last one here is the metallic, and I'll drop that in there. And now, concrete should definitely not be smooth. So I'm going to bring that all the way to the left to make it really rough. And it looks, I'm just trying to adjust this. It's really dark. But if we go in, if the light hits it right, you can see that it does have a texture. And you can see that the normal map and the height map, what they do is they like fake texture, like it makes it look like it's not a perfectly smooth surface, which it is. It's just a perfectly flat plane. But the height map and the normal map help it render in a way that makes it actually look like a 3D, textured wall. So I'm going to swap out this floor material with these laminate floors instead of the ones that we were using before. So same thing, diffuse in the albedo, roughness in the metallic, normal in the normal, click Fix Now if it says it's not marked as a normal. And the, and then the diffuse one goes in the height map, and set the tiling. So, 5.5 actually looks pretty good for this one. And you can adjust the color if you want to give it a certain tint of any color, which is pretty cool. Okay, let's go ahead and set this felt albedo to the top of our pool table. Let's adjust the tiling. Yeah, there's these little weird words on it that show up on the texture when you do that. So I'm just going to leave it at 1. We can also, let's see. So it looks like there's some metal on that pool table. and there's also some wood. So we'll get back to that. Let's go to the walls again, and let's apply textures. Well, let's go back to the pool table. So let's do something with this metal material here. So let's drag in the diffuse to the albedo, drag in the displacement to the height, the normal to the normal, click Fix Now, and the roughness to the metallic. And we can zoom in here and kind of see what that did to our little metal caps here on our holes. And you can mess with the tiling if you want. Honestly, 1 looks okay. Maybe a little bigger than that would be better, but I'm just going to leave it at 1. And I am not going to mess with those 5 materials on the pool stick. However, if you're following along with the tutorial, which I hope you are, go ahead and throw textures all over anything you want. I mean, you can try to texture those lamps overhead, the pool stick, whatever you want to try to do. I'm just going to set up this, like, I think this table, like, yeah, this wood material doesn't look very good on here. Now, another thing that makes textures a little more complicated than just materials is that the 3D model has data inside of it about how the texture should like wrap around it. Like, is it a sphere? Is it a square? Stuff like that. So if the people making the 3D models don't have those, they're called UV coordinates. If they don't have the UV coordinates set well, just everything's going to look bad. So you can see, like, on the bottom of this table, that wood actually looks pretty good. I mean, the size of it, the scale, and the direction that the grain is running. But here on the top of the table, it just kind of looks bad. So I'm going to edit the red materials on the wall. I'm going to use this denim fabric. So again, diffuse goes to albedo, normal goes to normal, hit Fix Now if you get that little error message that it's a not marked as a normal. The displacement goes to height, and then the roughness goes to metallic. Go ahead and adjust it. You know, denim is not shiny, well, usually. So I'm going to bring the roughness all the way down. I'm going to adjust the color, make it a little bit brighter. You can kind of see how it's got a little bit of texturing on it. So you can adjust the value of this normal map, like how strongly it's applied, to make it look more bumpy or less bumpy. So I think 1 looks okay. That's not bad. And let's do this like stripe between the black and the red section. And I'm going to make this one this dark wood. So I'm going to drag them all in. Same places that we've been doing. Make it a little rougher. And, you know, we could adjust the color tint if we wanted to. We could mess with the tiling. So yeah, I think that looks a little more realistic. 5 and 5 on the tiling. You can adjust the height map and the normal map. Both of them affect how like bumpy the surface looks. So yeah, just kind of have fun and set up the materials and all the textures how you want. And yeah, so here it is. This is the game. You're done. Thank you so much for watching. We really appreciate it. Please like and subscribe if this was helpful to you. And we hope to see you in the next video. See you later.